My pleasure to introduce Bob Larocque, who's the chair of the next panel. He is the executive director of the Canadian Fuels Association, a great colleague to Advance Biofuels Canada, a good friend, and someone whose beard I am very jealous of. It's so good. So I'll let you introduce the panel.
I'm getting ready for Christmas. All right, well, good morning, everyone. If I could have Michelle and Chris, please come. Oh, there we go. Come sit down. We're going to do this. First and foremost, I just want to say thank you to Jeff. I was reminiscing last night, Jeff, 9 years ago. And I know we have a lot more work to do, but to see where we are today compared to 9 years ago, I think a lot of us in the room have put a lot of effort into the bioeconomy, and we're on our way, is what I'm trying to say. So I just want to say thank you, Jeff, for the invite today. Yeah, I know. I was on the forest industry until 2020. So my name is Bob Larocque. I'm President and CEO of the Canadian Fuels Association. And where's the clicker? And I'm pleased to be here today with two of my colleagues, Michelle Belisle, who is the Air Quality and Greenhouse Gas Manager at Imperial Oil, and Chris Verva, who is the Executive Director of the Canadian Oilseed Processors Association. And when Jeff and I talked about in May or something like that, he said, Bob, and we're going to talk about carbon intensity at the next scaling up. And I said, oh my God, Jeff, can we please go on stage and talk about CI? And we were having some conversation last night about technologies and whatever, and people are very nice. I'm Bob, what's your name, whatever, this is what I do. My second question was, and people will know that in the room, is what's your CI? The only thing we talk about is what's your CI. And we'll talk about a little bit more today about why carbon intensity matters. So who we are at the Canadian Fuels Association, we represent most of the transportation fuel sector. We supply 95% of all the fuels in Canada, and soon sustainable aviation fuel. And also recently, our members produce more than 70% of all of Canada's biofuel. We have 16 refineries. We have biofuel production, 10 to 12 in our membership. We have more than 75 terminals. So when Scott was talking about terminals and supply chain, that's where we're at. And more than 12,000 commercial and retail sites across the country. But why carbon intensity? Well, first, it's in regulation. We've all heard about the Clean Fuel Regulation, the BC LCFS, the California LCFS. So it used to be about mandates about how much ethanol should I be putting in, or how much biodiesel, renewable diesel should I be putting in. But now it's about carbon intensity. We have to reduce the carbon intensity of our products in the clean fuel regs by 15% by 2030. So it's not about a blend mandate anymore, it's about reducing carbon intensity. And then just for you, those are the trajectory. I just picked gasoline and diesel, but it gives you an idea of our targets. Second one on why it matters is the credits. The credits are also based on carbon intensity. So if you see at the graph, by 2023, we had to reduce our CI by 3.5. So if you make a CI of 10 or 15 points less, you get a 10-point CI reduction that you can monetize. But over time, that CI reduction reduces, so that's why the lower the CI, the better it is, because at some point, the CI is going to reach where we need to be, and you can't monetize that credit. Next one is carbon markets. We were lucky enough now, Environment Canada did publish their first results in July. And that's where we're at for the federal clean fuel regulation. Just putting some numbers out there, but the average price for 2023 was running around $127 a ton. And then in BC, they publish it every quarter, and you can see the different ranges. So the credit market is very, very important, and I think Michelle's going to talk about the significance in millions of dollars of what that means. The incentives, so when we work with the federal government, it's all about CI. So on hydrogen, for example, it's not colors. If you make green, you're going to get this. If you make orange, you're going to get this. It doesn't matter the color. It matters about what your CI is. So if you can reduce your CI by, and you'll see there, then you get the 40% capital CapEx tax credit. If you make it between such and such, it's 25. And if you can't reach 4, you get nothing. That's why we ask the question, what's your CI? So we can figure out what we can get. And then the Americans are doing the same thing. Right? It's all about your CI reduction, and then you can get different points. I think Mike McAdams was talking about it yesterday. Depending on where your CI is, then you get a different cents per liter. So it's regulation, credit market, and incentives. That's the clean fuel regulation and the 45Z we keep hearing about. But all of that, what's behind it is the life cycle analysis. So we have a tool in Canada. Environment Canada's got a life cycle analysis tool. It's open and transparent, and we like that about it. But there's also the GREET model. There's also the ICAO and IMO. And unfortunately, and we heard about it, they don't look at the same life cycle. Their CI is different depending on what tool you use. And I think that is something that we need to work on. We need to be able to standardize that because it is very important. The other thing for us, and I think Chris is going to talk about it, and that's why Chris and I talk about this, I don't know, once a week. Feedstock is a big, big part of the carbon intensity. It doesn't matter if it's agriculture, energy, when you're making low carbon hydrogen, where's your electricity coming from? The feedstock is very, very important. Then it's your actual production, so how much energy do you use on site to produce your product, which is another 20-30% in our world. And then after that, the use of the finished fuel, which is smaller in our world. So because of all of this, we talk about CI all the time, and I will switch it now, because I'll let my speakers speak about why it matters. So Michelle's going to talk about it from an industrial perspective, and Chris is going to talk about it from an agricultural perspective. So the first question I have, oh, and by the way, please, if you have any questions on carbon intensity for our guests, please, Jeff, do the thing, and then you can bring it out. I have about 3 questions I want to ask our panelists, but we have about 10 minutes at the end to answer any of the audience questions. So first question I have for both Michelle and Chris, and we're going to start with Michelle, is what has been the impact of a new CI world to your life or to your company?
Perfect. Is this great? This is on. Yeah, so thanks, Bob. Thanks for having me up here. So I'm Michelle Belisle. I'm with Imperial, and we're building a renewable diesel facility in the Strathcona area, so just outside of Edmonton. So I think the fact that we've been enabled, the policy has enabled us to build that is, obviously a huge impact. And the impact really from a fuels perspective of moving from or incorporating carbon intensity into the mix is enabling fuels regulations to move from blending mandates, which don't differentiate the CI of a fuel. It's really a volume-based mandate, so you need 2 or 5 or some specific percent, to a low-carbon fuel standard, which values and awards, as you showed on the previous slides, the carbon intensity of a fuel. So lower carbon intensity fuels would generate more credits under a low carbon fuel standard like CFR or BC LCFS, and that really provides a value to production and to lowering the CI and drives that continuous improvement throughout our industry. So we've got up on the screen here an example of a renewable diesel value chain, and I think it's important to understand for carbon intensity and through the life cycle analysis process that carbon emissions are accounted for and included in every stage of the value chain or the production of a product, in this case, renewable diesel. And so what carbon intensity does is allows every player in that value chain to evaluate are there economic or technically feasible opportunities to reduce the carbon and get that final product carbon intensity down. And then, you couple it with a policy like CFR and you really create value in that space. And I think that's what it's all about, is creating value.
Thank you so much. Chris?
Yeah, thanks, Bob. So the slide that's in front of everybody is often a slide that I'll use to try to explain why carbon intensity matters to a farmer audience, because as Bob says, this is kind of where the puck is going, right? It's really all about carbon intensity. Different programs around the world for biofuels are moving towards carbon intensity. And what I try to do when I talk about the subject of carbon intensity, again, most cases my audience is farmers, is what does this mean from a dollars and cents perspective? What does this mean from a competitive perspective? So when you look at the bar chart that we've put together on the value of carbon intensity, it is illustrative. This isn't something where these are exact numbers in the marketplace today, but we've done our best to use real values. So what you see on the bottom, on the x-axis, are the different feedstock based on different carbon intensity scores, roughly, in California. Because California happens to be the most transparent market as it relates to releasing this kind of information. So we hope in the future, by the way, that the Clean Fuel Regulation, the BCLCFS, starts to do a little bit better as well as it relates to publishing this type of information. But the best information we have right now is California. And again, on the bottom there, you'll see the different feedstock and the different carbon intensity scores for those feedstock. You'll see there is a wide variation. I think people that are in the biofuel space are largely aware of these different feedstocks. You got soybeans, you got canola, animal fat, used cooking oil. These are some of the key feedstocks that are being used in renewable diesel production today. And again, massive variance in carbon intensity. And that variance in carbon intensity has a very meaningful impact on the value of the fuels that are produced from these feedstocks. So the example we're using is, let's take a $1 billion a year renewable diesel facility production, and if they're using 100% used cooking oil, for example, at that facility as their feedstock, the credit revenue that they could generate from UCO is about $250 million a year, assuming a credit price of $100 a ton. You move to the far left side with soybeans, you're producing about $120 million in terms of revenue from credits. So if you're a renewable fuel producer, you're looking to get UCO every single day of the week. It just makes economic sense. So when I describe this to an audience, and specifically a farm audience, their key takeaway is, dang, like this is table stakes. We will have to compete on a carbon intensity going forward so that we are one of the preferred feedstocks going into the growing renewable fuel industries.
Thank you, Chris. Second one is that what are the benefits of a CI approach? And I'll start with Michelle and then go to Chris.
Thanks, Bob. I think the benefit is the technology neutrality of carbon intensity. So when you're using the life cycle assessment process, you're really looking, again, through a value chain. This is a renewable diesel value chain, but electricity is another one. So any product that you're looking at, you can really compare on a technology neutral basis, what are the greenhouse gas benefits that you're deriving from the use, and really direct that to your use case. So if you have, heavy duty trucking might have a different use case than light duty vehicles, and you can look at all of your options from a technology, from a vehicle and your fuels, and compare what are the greenhouse gas reductions compared to your kind of base case on there, and make the right choice for your use case. So it really changes the evaluation from just a cost basis in a volumetric blending mandate, right? You would just really look at the cost. What is the cost of this low CI fuel or renewable fuel that I'm putting in? And that's the only kind of piece of information that you're looking at. And it changes it from a cost evaluation to a cost abatement evaluation. And that's what Chris just showed on his last slide, was what's that cost of, what's that, dollars per ton of carbon abated. And it changes the entire narrative, and it really opens the field for, what would be in a blending mandate situation, too high of a cost alternative and fuel to blend in, and it opens up that aperture, I think, a lot, so that other fuels can kind of compete, and we create this and situation where we're not just looking at one specific fuel, but we're looking at a full suite of technology opportunities to evaluate, again, to get those greenhouse gas reductions in whatever use case you're in.
Thank you. Chris.
Yeah, if you can put the slide up again, actually. These days, in my world, and the farmers or the oilseed processing companies that I talk to on a daily basis, we're questioning what the benefit is of carbon intensity, to be honest with you, because you look at the variance, right? And again, it's all about competition and getting your hands on the lowest carbon intensity feedstock. And again, this is illustrative. This is California, but this dynamic is really no different in the Clean Fuel Regulation and the BCLCFS. So-called waste feedstock get the lowest carbon intensity all the time. So at the moment, we're kind of scratching our heads, and I'll talk a little bit more about challenges later. There are clearly some benefits to carbon intensity, and I think one of the biggest ones from our perspective is it's a less blunt of an instrument in terms of trying to do what we all want to try to achieve, which is reducing emissions. So the alternative to carbon intensity reductions is absolute emission reductions, and that's a lot more challenging for our sector and arguably for all sectors. So the fact that carbon intensity is the measurement in programs for biofuels, we think is a good thing. So there's opportunities to, of course, reduce emissions, and that can be done through different innovations in farming practices, using maybe some in fertilizers that don't emit as much emissions. There's so much progress being made in precision agriculture, so you're using your inputs a lot more efficiently. So there are some opportunities to reduce these emissions, let's call it the numerator, right? But there's also opportunities to improve your carbon intensity through productivity gains. And that's something that the agriculture and crop sector specifically has been really good at for decades, if not centuries. We have been able to increase our productivity. We've been able to produce more on the same amount of land. And again, that is accounted for in the carbon intensity equation, the denominator, if you will. And that is something that we feel does benefit agriculture and is a role for us to reduce our emissions, or carbon intensity emissions, by the very virtue of doing what we've been doing for centuries, which is to increase our productivity.
Thanks, Chris. Again, if anyone has any questions, please send them up. But then it's like everything, we like it to a certain point, but what are the challenges that you're facing on the carbon intensity file? So I'll start with Michelle and then Chris.
Yeah, I won't repeat what I think a number of speakers have said over the course of this last day and a half, but just the inconsistencies and the multiple different LCA models that will result in different carbon intensities for the same product. So that can kind of distort the market, where one market will value one feedstock or one product more so than another, and you could get some real inefficiencies there in terms of shifting products across boundaries, just to kind of realize that arbitrage that exists because of those different systems. And then I would say also, even so between systems is one thing, but within one system and the application of an LCA model, those specifications even within an LCA tool is really important. And so one example that I would bring forward is for the CFR LCA tool ECCC's developed. In their specification document on indirect accounting, so this is kind of book and claim treatment of RNG, you require a direct connection from the RNG kind of producer to the facility to be able to account for that RNG in your carbon intensity, except for feedstock for hydrogen. So then you really take out that technology neutral approach that LCA and CI gives you and start choosing winners and losers within that process. So those are some of the challenges that we're facing right now, and hopefully we can get resolved as this becomes more commonplace.
Just before,
Sure, go.
Is that all right?
Of course.
Okay. No, there's one more too that I want people to, that we dealt with, is on the incentive side. And the IRA came out, and the Canadian government decided, hey, we'll do something on hydrogen, for example, on the ITCs, but they just use the same thresholds on CI, assuming the American GREET model. And then when you apply it to the Canadian model, because it is different, suddenly the same technology used in Canada does not qualify for the same amount of the CI reduction because the way the CI was calculated. So again, when policy people in government, you're looking at a CI approach, we support it, but the devil's in the details about what LCA tool did you use. And that one had a significant, I think, we all thought we could get some of the 30 to 40% range on the capital investment, and then once the calculation came out using the Canadian tool, I think there was only one project that could meet the 30%, and everyone was in the 20% below. So again, depending on what tool you use, be aware when you're try to compare with other CI initiatives around the world. Chris?
Bob, I think just on that one, right, this is the classic case of, using it like inches versus centimeters, right? Like which side of the ruler you use is really important. And we've tried to, bring that forward, is that it's as simple as that, right? You really need to be understanding how you're measuring and what's the difference in measuring to be able to compare these things. And so that definitely is a challenge.
Yeah, so maybe to build on something you said, Michelle, and something that we heard yesterday as well, one of the biggest challenges that we've identified, and again, I think it was said very well yesterday by a couple of speakers, we get it, CI is where the puck is going, the whole concept of technology agnostic and all that kind of good stuff. But as a feedstock provider these days, we feel like there are winners and losers as you take a carbon intensity approach towards feedstock. And again, I'll keep harping back to the slide that's on the screen. The winner is UCO. The loser right now are crop-based feedstocks in these low carbon fuel standard programs, whether it's in Canada and the United States. I don't know if that was necessarily the intent, but this is where we find ourselves today as an agriculture stakeholder in the biofuel space. Yes, we can start to work towards a better carbon intensity score. We are doing that today. We've always been doing that, frankly speaking. But we have such a massive delta to make up between some of the so-called waste feedstock and the crop-based feedstock. So our biggest challenge is right now, and this is the same thing that's unfolding in the United States as it relates to winners and losers. At the moment, crop-based feedstock, we feel like the losers. For anybody who is reading headlines, largely in agriculture publications, and I recognize maybe this room doesn't read a lot of agriculture publications, but even in the mainstream, you see in the United States, the soybean farmers, the agriculture complex at the moment asking some really hard and important questions on what's in it for us. Everything is being provided for a certain feedstock. And again, UCO is really the feedstock right now that is displacing demand for the crop-based feedstock that, again, these markets have become so important for us that we've helped build, but we still find ourselves being challenged to participate because of this dynamic of carbon intensity ultimately choosing winners and losers.
Oh.
My apologies. UCO stands for used cooking oil. Thanks, Jeff.
And where does it come from right now? I'm just kidding.
Sure.
You can answer that one if you want. I got a question from the audience, and I think it's a little bit outside, but I'd be curious. How about a national low-carbon strategy rather than a national bioeconomy strategy? And I think that's a good question. I'll let you answer. But I'll take that one, too, from my perspective. And I think I would agree with that. I think there's a next... I think Canada needs to expand and monetize bioeconomy type products. You need to be able to monetize your bioplastics, your lignin, we see it a little bit in construction products. I think there's some procurement coming up that are looking at carbon intensity versus cement, steel, tall wood, but we don't see it on consumer products. We don't see it on anything. And I think if we went down that road, multiple benefits, because then you can work with your supply chain and look at your feedstock, look at your production. Right now, I don't see that being monetized as much as we're seeing it through the carbon intensity world, where we do have a carbon market. It is open and transparent, and you can look at your supply chain on where you can make reductions. So I would support having more of a low carbon CI approach to products than the bioeconomy type targets that we've seen. Do you have any comment?
Yeah, I think that's an interesting concept, right? I mean, at the moment, there are only select markets that are focusing on carbon intensity. And as society, we think we're doing the right thing, right? So we're taking low carbon feedstock and putting it into biofuels to abate emissions from transportation fuels. But our sector produces a product, our agriculture supply chain produce products that are multi-purpose. So yes, we have an opportunity to sell some of our products into the low carbon fuel markets and abate GHG emissions. But there's also other markets, food markets, feed markets, industrial markets, where carbon isn't accounted for. So again, as the pieces move around the chessboard, if not everybody in the different sectors that we satisfy are using a carbon approach, maybe there isn't actually a net benefit or a net gain in GHG emission reductions overall. It just sort of moves the pieces around the board, if that makes sense.
Yeah, Chris, I completely agree. I think when we look at going from bioeconomy to a low carbon economy, it follows the evolution. I'll just stick with the fuels kind of space, right, where we started with renewable blending standards because we know there was some reduction, but you can't quantify that in a blending standard because you don't have the carbon intensity. And so moving from a bio standard where we think, I'll say no, but at least think that there's some greenhouse gas benefit to a carbon-based standard where we can quantify that benefit and choose the products and choose the placement of where to kind of invest money and resources in. Moving from just the bio to a CI base really helps us quantify what the benefits of any action that we're taking, and choose the right actions. And so, hopefully avoid missteps on, investing in something that maybe isn't as beneficial as we thought just because it has the word bio in it.
Thank you. Next question I have, moving forward, using CI means the market will pick winners, not governments. Comments? Yes.
Hear, hear.
Yay.
Yep.
Hear. But does anyone want to start with that one? Or?
Yeah, I'll jump in. I mean, I think that's what we want, right? So we want a market-based approach where we'll let the market dictate based on product demand, consumer demand, and value the products based on greenhouse gas emission reductions. So I think we've seen, right, nobody can forecast the future, and governments don't always do the best job at choosing which product. I think we can look to Europe and diesel being the answer to everything that has changed in recent years. So let the markets speak, and that'll really garner the most cost-effective solutions, right? So when you let the market do something versus choosing one specific technology, you really allow those cost-effective solutions to come in, and that means the winners are those who are achieving those greenhouse gas objectives in the most cost-effective manner, and that's going to solve some affordability issues too, right? So it's really a win-win.
No, I totally agree, Michelle, and we've done some analysis on that as we were working towards blend mandates versus CI, that there is a benefit to consumer from an affordability perspective.
I have nothing to add. Well said.
Cool. There is another one here. It's a little bit outside of CI, but maybe we'll take a CI angle to it. It's regarding carbon capture and storage. What is the state of the technology for CCS? Capital, cost, effectiveness, TRL. And I think, do you want to answer that one, or do you want me to take it? Or?
I mean, I can start. So CCUS isn't my area of expertise specifically, but I mean, I think we've got it demonstrated, worldwide that carbon capture and storage is, commercially ready and in application across the globe. So this is something, obviously it's going to be very jurisdiction specific. You need the reservoirs and that storage capacity. But I think when you look on this value chain, right, we've got CCUS on here as one of the potential decarbonization steps. It can go into, in this example, right, it's supporting a low CI hydrogen production. But really, I think the benefit and the value in CI is that you can look at a technology like CCUS and ask yourself, and we can all ask ourselves, does it make sense in any of these steps through the value chain? And what's the benefit going to be? And again, you're going to that cost abatement. So is that your most effective cost abatement? And you go through that cost abatement curve and you kind of choose your low-hanging fruit first, and as you move to the right of that curve, CCUS fits somewhere in there on that cost abatement curve, and you just decide, does this make sense at this point in time to implement CCUS?
And I think I would add also for the audience, if you don't know, there is one existing facility, Northwest Redwater, who is doing CCS. They've been doing it for 3 years, 4 years, and they are generating carbon intensity reduction under the clean fuel regulation. So again, that is part of the CI calculation. So they are generating credits. And I think a lot of us in industry, at least from our perspective, we were waiting to see what the tax credit was going to be. Yes, we finally got it announced. There's still some issues about implementing it. We heard from Derek yesterday on the forestry side. So I think Alberta will be the next wave, and we'll see a couple more projects on the carbon capture. And I think in other places in the country, you're absolutely right. We're waiting to see where we're going to put this, what's the infrastructure. I know there's a lot of work in Ontario. We might hear from the Ontario government next, but things are evolving in the CCS, but I think Alberta will be the next wave.
Yeah, and Ontario actually just released their draft framework earlier this week. So they're well on their way, and I think 2025 is where they're looking for a regulation. So, I mean, again, I think it's a proven technology that definitely has a space in the decarbonization, and in reducing CI of many products, not just fuels.
Yeah, on industrial CCUS, I mean, again, I represent farmers and the agriculture sector, so we're not really looking at industrial carbon capture, of course, but maybe I'll take the question and use that as an opportunity just to highlight that Canadian farmers are probably the biggest sequesters of carbon in all of Canada. So planting crops like canola, soybeans, corn naturally takes CO2 from the air, right? Photosynthesis converts it to energy. And a lot of the biomass that's left behind from crops gets recycled back into the soil. And one of probably the biggest innovations that has taken place in Canada over the last 30 years, and this was not because of biofuels or chasing lower carbon, this was just something that was helpful for farmers in terms of preserving moisture and making more efficient use of their land, is something called minimal and zero till. So, for example, 90% of the land that's farmed in Saskatchewan uses minimal and zero till. So that essentially means that when a farmer is seeding their crop, they are not tilling the field at all. So it's not releasing any carbon that's been stored in the soil. And this practice is captured in Canada. This practice is reflected in the carbon intensity score in Canada. Oddly, it is not reflected in models in the United States, where, again, that disparity in terms of, let's say, the science or the assumptions that are made for carbon intensity calculations are just different. But again, I just wanted to flag that in Canada, farmers are already doing great things as it relates to taking CO2 out of the atmosphere.
And on behalf of our sector, Chris, keep doing it. We love canola, so. Good. If there's any more questions, I think we have another 4 minutes, but I have one more I'd like to ask. So, Michelle, if you had any advice on how to incorporate CI, either from an industry perspective or government, what would it be?
If I start on the policy side, I think, whether it's fuels policy, any kind of policy, the most important thing to start with is really clear and transparent objectives. So why are we putting this policy in place? Why is the government putting a policy in place? And once you have that really clear objective, you can start incorporating and considering what's the most effective way to reach that objective. And I think when we look at, right, as we've talked about, CI is probably in anything that's a greenhouse gas reduction objective, the best way to get that, because you drive that cost abatement, you drive those most effective carbon reductions to society, and then we can start moving on from there. And from an industry perspective, I would just say seek the value. Right? It's all about where the value is. And so carbon intensity allows us to ask questions and drive the innovation, as Chris is talking about, and recognize the innovation that's happening across the sector to reduce carbon, and it values it. So you can really incense continuous improvement in terms of carbon reduction.
Thank you.
I agree with everything that you just said, Michelle. Again, really well said. I'll just add that, again, I've been working on biofuels on behalf of the canola industry for maybe 5 years now. So my eyes are getting a little bit more wide open in terms of this carbon intensity journey that we're on. So one piece of advice that I would provide to any business, even my own members these days, to government, is tread carefully. Think about the unintended consequences of different assumptions that are being applied towards carbon intensity calculations. Think about the science. Again, we hang our hat on science and say, this is good science, this must be good. But look at that science, critique the science, and also weigh the science and the goal of GHG emission reductions against what we think is also important as it relates to carbon intensity and monetization of carbon, which is, what is the economic opportunity? Why are we doing this? We're doing this because, of course, we want to reduce emissions, but we also want to scale up. We want to see economic opportunity occur in Canada. And frankly speaking, I don't think that we're always getting that right at the moment as it relates to, again, the carbon intensity estimates and the journey that we've been on thus far.
Thank you very much, and we're on time, so thank you so much, Michelle. Thank you, Chris, and thank you, everyone, for being here today. Really appreciate it.